intensely involved in this Gilliman book, which we showed earlier, to get the full picture of what all the theory is behind this, which will eventually get incorporated into a book form.
Is that related to the network experiments that you're doing?
Yeah, the network. He has 2 volumes. One of them deals more with the lumped component stuff, and then this one deals with the transmission lines and loading sections and all that type of stuff, and filter theory. Filter theory is probably one of the most difficult areas in electrical engineering. The mathematics is extreme. Nothing really resolves into simple relationships, and a lot of it was developed on notions and ideas, and it's really it's not really a resolved subject. It kind of just keeps getting more and more complicated, and doesn't lead you to any final results. So I have another book here that's of the same genre, the Bell Telephone Mathematicians, and this one's been very helpful. This one is really very straightforward. All of these books are that if you know algebra, you basically can comprehend the entire book. But it's a long process. Each book's about 4 years. Yeah.
What's the title of that?
This one. So you just got this one off the internet recently. So
okay, this is one I sent.
Yeah, I've already gotten a lot of really good material out of this. So, but this book basically emphasizes the design of these amplifiers that connect to these long lines. And the design requirements are severe because of the voltage surges and the wide bandwidths and the wide amplitude ranges and the noise requirements. So that's what takes these special Western Electric tubes, which now I have a pretty good gathering of. I have enough tubes now that I need. At least I got that part to build these special amplifiers. So that's that kind of keeps me busy. That's what I've been working on pretty much full time. So this book I've spent a month on, 6 hours every day, either between that or the other book, trying to get the network situation better understood. And then the notebook is starting on the antenna project out there, but that's rather primordial. But here's our basic antenna structure. These are all the poles. Not drawn to scale, and these are showing where all the loading sections. This is what we drove through out there. So that's basically the diagram of what's going up. So let me see if I can get in a position I can point some things out. So there's 3 pairs on the pole. So the pole pair is the center one. That's the Alexanderson pair, and then there's 2 carrier pairs on the outside, and then that either makes up the beverage antennas or it's used to analyze the phases on the Alexanderson antenna. So basically this is a structure in which to scientifically analyze the Alexanderson antenna and the extensions of the theory that I've made. So what you have to do is you have one transmission line that goes to the end that can measure the phase and amplitude at the end of the one, but you can't just connect your equipment straight for the other end of the line, because the time delay and the propagations of this will not be the same because one of them doesn't have it. So you have to have one line that goes halfway and then comes back again. So we have to configure this thing. That's where the field telephone wire comes in handy, because it's its own individual pairs. Then we can use the pairs within the pairs to be able to get it where we have one length of line where it goes from here halfway and back, and then that measures the input of the antenna, and then we have another length of line which is equivalent, which goes from here, but instead of going back, goes to the end, and that goes to the output, and that way then it's possible to study the transmission characteristics of the structure in between. So that's, normally I would have another cross arm carrying more pairs, but we don't have that kind of material. So the field telephone wire will help, because we'll just use 2 pieces of field telephone wire. So that'll give us enough to zigzag back, where if I did an open wire, I'd have to put one more pair on here to balance the thing. So, and then this is the rolls of field telephone wire to be used. And these are the loading sections. So these are the points which connect to the interior of the Earth. So for economy reasons, we're only going to start with every other one. So there'll be the origin or 0, and then 2, and then 4, and then 6, and then the terminal. But then later on, then we'll put in more. We'll put in another loading section, and because there has to be at least 8 lumped sections in order to start to approximate a uniform line like we saw with the network stuff. Another complication is the poles are not uniformly spaced, and that makes things really difficult, but for the most part it averages out fairly well. So the important thing is we do have one pole number 38, that's the exact halfway point. It's very fortunate that worked out. So what this indicates, the transpositions, is every so often down the line you have to twist the wires over so that the power line interference and static doesn't build up on one and not the other and cause it to induce in the system. So at the loading sections, the outside pairs are twisted on the transposition brackets. I don't have anything right here. Actually, I do. I can show this. So this is the telephone company.
Can you see the cover again?
Oh, this is a very good book. If anyone that wants to learn the basics of this stuff, this really is the book to start. Even though it tends to use, electron theory analogies and stuff, it does qualify the fact that these are only theories and doesn't get too married to them. So you got your basic, boys' book of electricity circuits and meters, but it keeps going, and it gets more and more sophisticated. It gets into how the telephone system works, and it shows you pictures of the generators and give you some basic principles of how the generators work for the DC. Yeah, but very thorough, but very highly simplified, and then it gets more and more involved theoretically, but it's all very understandable. So it has, this is what I'm working on now. This is the basic network stuff where you're simulating the lines with lumped components. So this is like the networks on the bench. These are the derived equations. What I'm working on here is none of this does me any good unless I can derive all these equations myself out of my head with no book. So that's what I'm endeavoring to do now. So this is an analog, lumped analog of a certain length of telephone line, where this is the resistance of the wires and this is the leakage of the insulators, and then also the inductance and capacitance, and then they're showing the phases. And this is all the stuff we did yesterday on the bench. So except we had a very unique telephone line on the bench that went through counter space rather than space. So these are the things we showed on the oscilloscope. So then it keeps going with coaxial. But then we get to the point right now we're interested in the hardware end of it. So, okay, these are our basic open wire structures. So this type of structure is for voice frequencies only. The pairs are not well defined. The spacing is equal, and because the frequencies are so low, you don't have to worry about too much crosstalk, and that way you can get more wires on the pole. But then as the frequencies go up, you've got to start tightening the spacing between the wires. So this is the configuration we're using right now, where we have a pole pair, and then we have the carrier pairs. But what we're doing is we're eliminating these two so that we can keep better isolation between the pole pair and the outside one. So that's basically what's going up. So we have one pair of wires in the middle, and then we have one pair of wires on each outside end of the line. Then as the frequency increases, you have to tighten these things up even more, until eventually when you get up in the megacycle range, they have to be very close together. The wires have to be very tight so that they don't swing or move. So the engineering becomes more difficult, but this is the O-carrier type system. Back then it was C-carrier, and that's what we're adopting as our, I don't think there's any kind of lines, so I want to get into the transpositions. Back. So this is the actual, this might be kind of hard to see, but these are the transposition brackets. So what you have to do is every so many poles, depending upon what transposition plan you deal with, is each one of these is a pole, and then after a certain number of poles, the wires get twisted over, and then that equalizes so that no one side is exposed to a source of noise, but ultimately the other side is, so the noise signals cancel out, and the line remains electromagnetically enclosed. So this is a transposition arrangement here, but I think the picture's too fuzzy to see. Here's one bracket here. And I think they have some of the, you still going on that? Here's the carrier equipment. They're talking about the carrier equipment that we got. This is showing the basic mechanics of it, the O and the N systems. Block diagrams, and there's one of the units here, and then this gives a very basic explanation how each of the modules operates and how the frequencies are translated around, and all in a very simplified form. There's nothing in here that the beginner can't understand, assuming he starts from the beginning. It's an extremely valuable book. I don't know how easy it is to find anymore. This gets into all the modulators. These are the things that translate frequencies, so these are going to be very important in the seismograph situation, because the earth signal mechanically is too low a frequency to hear for the most part, other than, having some bass speakers and some good amplifiers will work. There'll be a lot that can be heard that way. But the carrier system converts them into musical tones, and then that way you can hear by the pulsation of the tones and their frequency, you can hear the ground movement. So it's going to be a very interesting experiment. This is one of the things I did at Landers. They had the talking seismograph, where there's a space shuttle toy and a recording of some space shuttle event that had the right words in it for earthquake. And anytime there was an earthquake, it would set that thing off, and you could tell by the stuttering of the voice and how often it did it what was going on with the earthquake, so you knew when it was time to come in the house and look at the seismographs. I think that's shown in one of the Landers videos, is when I was showing the power company guys around and the voice thing went off. So this one's going to be more advanced because we got an XYZ seismograph system. So the whole idea is to use 3 musical tones and then amplify them, and there will always be this kind of like wind chimes in the background that will represent the actual movements of the earth. And during an earthquake, they will become insanely loud and give indication that you better come running and look at something on the graphs.
So I think that's in a long 4-hour video.
That's in the kind of cruddy one,
okay.
not the Tesla Society one, but the other one, was just that was just a friend of mine that recorded that for his own records.
And that ended with a sunset or something like that. Okay, yeah. All those Lander videos.
That was never intended for publication.
Right.
So hopefully a lot of stuff got edited out of there, because I got into some real shipyard verbiage that might offend some people.
It is edited. But yeah, the long 4-hour one and then that one that you're talking about, those are both available through extraluminaltransmission.com. People can get the Landers videos as part of the package.
So I think that kind of wraps it up. I don't know if we can think of something else.
Okay. Any final words or any requests? Or
No, I think everything is straightforward.
Got a lot of stuff here to do. Shelves and equipment, and a lot of good work going on at the seismic project. And again, for those of you who have not followed that too much, you may have already seen the videos that we did up on the hill showing the different poles and wires and the shack at the top of the hill and the mine. And that's just one location. And there's a sister location out at a different different area. One is a east location, one's a west location, and with both of the systems put in place, it'll be able to kind of give you a stereo effect where you can not only can you see that the earthquake is coming, but it'll help you kind of pinpoint the location.
Yeah.
That's kind of the idea behind
Right.
the stereo effect from two separate systems.
You can get a directionality on it. The only drawback that the setup is we're not really in the place that's going to get hit by the disastrous earthquake, and the earth signals only go about, the underground ones only go about 200 to 400 miles, so we're right at the fringe of that. I keep pointing out that it would be wise for somebody or some agency or whatever that's got the money to accelerate this and get past this scientific and engineering analysis and get the stuff up in the area where it's really needed. But in order to move fast like that and whatever, it's estimated to be $3 million per installation. I mean, to begin with, it seems like, well, $3 million, that's crazy. But what you find is the accumulations. You know, all the stuff that adds up, and there's not that much more material around that I can salvage to make these things out of. So I only have about, the resources available to be harvested only occupy, you know, a fraction of the total requirement of wire and all that. So that drives the cost way up, because then you're going to have to figure out what are you going to do for insulators. They don't make carrier insulators anymore. The wire expense would be hideous. The cross arms, the power company is the phone company is just drifting further and further away from this technology, and we're finding, you know, that even though we have the money to buy the stuff new, nothing's being made anymore. So there's this massive infrastructure breakdown in this country right now in the engineering world, where in a few more years it will no longer be possible to do anything other than peck your device. Everything will be digitized, nothing will be real, no parts will be available. I can't even get replacement 8-foot Citizen band radio whips for my car anymore, not alone trying to buy 13-inch tires. And then if something else screws up, the parts are just simply not available. Yeah, there is one other thing I wanted to show, what critical Western Electric tubes we use for this stuff. I'll put it on the desk. So we've been going crazy on eBay trying to get the last of the resistors and the capacitors and all that kind of stuff, which turns into another big job. I wish I had a whole army of people to help me, because there's so many things that need to be done. So the first tube that really is the mainstay in building this stuff is it's a 396A. This is what the tube looks like. I'll actually go out and take pictures of them. So,
which number is it your finger's covering?
That's 396A. Yeah. So, and then it has the basic specifications on the thing here. And this is similar to the tube used also in the O carrier equipment. So getting all this O carrier equipment has helped provide for that one. And the O carrier, that tube has a different filament voltage, and it's known as the 407A. This is where the 396 operates with a 6-volt filament. This operates with a 20-volt filament, or a 40, which makes it more suited for DC supplied systems, because then you either have a 24 or 48 volt station battery, and then you can light the tubes without any AC transformers. And then the 404, that is a wideband one. That one is used right up front in the antenna circuits to get to repeat the signal from all the losses and the loading sections and all of that back up to the same voltage as it is in the earth. You have to have what's called a repeater. It's a type of amplifier that restores the signal to its original value without intermod or distortion or any other complications that mask the signal with the noise. The 403B is an earlier version of that, the 6AK5, those are readily available. So fortunately, some of these have Navy numbers. So this one's a 5670. So it's obviously it's not as good as the Western Electric. These tubes never wore out. They had a life of 10, 15 years, where consumer tubes had a life of like 1 to 1.5 years. So the Navy stuff is like halfway in between. So that's about all we're able to find so far that's affordable, because the prices are so high on this stuff now. Here, because of the voltage surges and the wide bandwidths and the wide amplitude ranges and the noise requirements. So that's what takes these special Western Electric tubes, which now I have a pretty good gathering of. I have enough tubes now that I need. At least I got that part to build these special amplifiers. So that's that kind of keeps me busy. Developed on notions and ideas, and it's really it's not really a resolved subject. It kind of just keeps getting more and more complicated, and doesn't lead you to any like final result. So I have another book here that's of the same genre, The Bell Telephone Mathematicians, and this one's been very helpful. This one is really very straightforward. All of these books are the network
experiments that you're doing.
Yeah, the network. He has 2 volumes. One of them deals more with the lumped component stuff, and then this one deals with the transmission lines and loading sections and all that type of stuff, and filter theory. Filter theory is probably one of the most difficult areas in electrical engineering. The mathematics is extreme. Nothing really resolves into simple relationships, and a lot of it was the and I'm intensely involved in this Gilliman book, which we showed earlier, to get the full picture of what all the theory is behind this, which will eventually get incorporated into a book form.
Is that related to the network?
If you know algebra, you basically can comprehend the entire book, but it's a long process. Each book's about 4 years. Yeah.
What's the title of that?
This one. So you just got this one off the internet recently. So
okay, this is one I sent.
Yeah, I've already gotten a lot of really good material out of this. So, but this book basically emphasizes the design of these amplifiers that connect to these long lines, and the design requirements are severe.